Hey guys, we're looking at the area of trapezoids right now, unit 7.3. And a trapezoid is pretty much combinations of rectangles and triangles put together. There's a formula that you can see right here in the center of the first page. That formula is over on the sideboard as well. And we'll talk about what the parts mean as we do a couple examples. And then there's several pictures to kind of help you understand where the bases and the height are in the perspective of the shape itself. So we're going to go over to the back page of the front page, and we're going to do a couple questions using those values. So we're going to do start off with 1, and you can write this down on your notes. So what we have to identify first is if we have the bases and the height, because our formula again is 1/2. The two bases get added together, and then we multiply those two values by the height. So in this case, we have the two bases. The bases have to be parallel sides. So we can label those, base 1, base 2. And then the height has to be perpendicular to those, so the height ends up being 4. So when we put this in the formula, we have 1/2, 5 plus 22, times 4. And you could put that entire expression into the calculator, and what we'll end up getting is 27 times 2, which will be 54 centimeters squared. Now, another one we're going to look at is going to be question 3. So question 3, we only have a height, 5, and one of the bases. We don't have the second base. So we have to figure that part out. Now, the first thing is I noticed that there's 8 on a rectangle on the left, so I can label this bottom part 8. But then I have to figure out this other part. I'm going to label that part x, because those two numbers together will give me base 2. So I have a 5 for the height, which I know from the other side of the rectangle, and I have 13 in x. I'm going to have to use Pythagorean theorem again. So when I use that, I plug in 5 for A and 13 for C, and then X would go in for B. And A and B are interchangeable. But after I solve this, which we've seen on a couple other assignments, you're going to get 12 for this. So X would be 12. So if we put it in the formula now, we have 1/2, base 1 plus base 2, 8 plus 20, 20 from the 12 and 8, times the height, which is 5. So after you take that and put it into the formula, you're going to get an area of 70 centimeters squared. So when you're looking at these examples, just make sure that you do figure out what the bases and the height are. Now, I'm going to take a look at question 5. We'll do 5 together. I'm going to erase some of this other material. So I'm going to start by looking at question 5 right here. Now we don't have much, but we have an angle, 60. And it's going to be very important that we find the height, because that height is going to be the same, because this is a square, and all 4 of these sides will be the same, so that'll give us a lot of information. Now I'm going to label each of the sides. So I have a hypotenuse, we have an opposite, we have an adjacent. And because I have opposite and adjacent, I'm going to use tangent for this one. So we're going to do tangent of 60 degrees equals x over 4. And I'll start by cross multiplying that. So I'm going to take the calculator, and I'm going to put in the calculator tangent of 60 times 4. And we end up getting, we'll call it 6.9. We're on to the nearest 10th. So that's 6.9. And each of these 4 sides are now going to be 6.9. So now I can look through and say, hey, I got everything I need. I have for my formula, we have the 1/2. Base 1 is 6.9. Base 2 would be 10.9. And then we have a height of 6.9. So I'm going to take that whole expression, type it in the calculator. We got 1 divided by 2. We got 6.9 plus 10.9. Close my parenthesis. Times another 6.9. And then we get an area. We'll round to the nearest tenth. We'll call it 61.4 centimeters squared. So, as you're looking through each of these, make sure you have each base. Look for the height, should be perpendicular to those bases. And be aware you may have to use Pythagorean theorem or sine, cosine, and tangent to help you find some of the missing measurements.